This is the April 2022 edition of the Mount Vernon Monthly Clinic, 4th Division PNR NMRA function.
Okay, this is just what I hope you can expect tonight. I'm going to talk about some of the architectural details, things like windows, doors, corbels, that sort of thing, and other parts of the structure itself, and some freestanding elements of whatever scene you're trying to establish. Mostly information about exterior parts and details, but toward the end, some interior details. Some are very simple and broadly useful. I hope there'll be some ideas that all of you can use. Others are more specialized or complicated, and I know that not a lot of modelers are going to use them. Well, let's start with something that I know every modeler needs is ladders. Of course, if you build kits, there'll be ladders included probably, but still you can use some ladders in your scenes. I several years ago made this jig for ladders. It's a simple styrene jig with an assumption that the ladder jacks would be 2x4s and that the ladder rails would be either 1x4 or 2x4. These first three panels show the jig itself, and then under construction, putting in the stiles or stairs. And I cut them over length. They're just so much easier to manage than if you try to be precise at this point. So I just cut them a little extra long and glue them in place. Here's the finished ladder. The little holes in the track of the jig are to help push the ladder out from the back. It can be fairly delicate, and so the tip of a paper clip or something like that can be used to push it out without damaging one of the steps. And so then you get a finished ladder that looks like this. Just trim it and you're all done. And everybody can use a lot of ladders. These are some structures I built that had an unusual amount of ladder. This ladder on the back of this coaling station must be about 3 or 4 stories tall, and this is a pretty tall ladder here as well. I didn't mention, I guess, but I hope it was obvious that the ladder can be any length of this jig. If you have longer rails, you can just finish a few feet and then push the ladder up and continue assembly. And the ladders can be either integral parts of a structure that you're creating, or just part of the scene, as a lot of railroad scenes have ladders laying around or leaning against a wall someplace. Another simple thing you can do is cover a wooden block or a dowel or a cardboard tube with strip wood and create yourself a crate or a tub or a tank. This crate is about the size of a couple of sugar cubes built over a wooden block like this one here. This is a tank that's actually just tub size. It's about 3/4 of an inch, I think, in diameter, which in O scale is 3 feet, and it was built around a piece of wooden dowel. This tank is a bigger rooftop tank, and it's probably 8 or 10 scale feet in diameter. I brought it up here in part to mention that I had made some band clamps from scratch. There are some available, or there were some available from Grantline. I don't know if they're still available through San Juan models or Grantline's replacement. But anyway, these I made just by taking a piece of styrene channel and adding a couple of nut bolt washer castings. Another thing you can do is just taper a block of wood and cover it with strip wood to make a coal bin, or in this other case, a large outdoor toolbox. We all need lots of track bumpers, and these are some ideas that I have used for track bumpers. These first two are the one I probably use most frequently, just a couple of posts with large timbers attached and some nut bolt washer detail. Another approach is these little bins with filled with topsoil or rocks or whatever happens to be handy. Here in this one, I've used literally just a loose stack of 3 or 4 ties. And in the final case, a more systematic approach by stacking some used railroad ties up against other railroad ties inserted as posts. Another thing that is very useful to a scene are stacks and piles of things. Here are 2 examples of piles of fairly new railroad ties. And incidentally, I point out in this slide that depending on the directions of view on the pile of railroad ties, you don't need to waste a lot of material if it's never going to be seen. So this one has a totally open-ended underside and back end, and this pile is hollow in the middle. I'd probably save 50 cents worth of scrap wood, wood strip by doing it that way. This is a more random pile of ties, and the little axe adds some interest. I model a logging railroad, so it's not surprising that there would be stacks of logs. And this stack here covered with tarp in the back of a rail truck is just several pieces of junk. There was, I believe, an HO scale tank car dome and a tire weight that I found on one of my walks on the roads in the vicinity. And there was some other piece of junk under there. I can't remember what it was. All just covered with Kleenex and painted with oak or stained with oak flow stain. And some more piles include these used pieces of rail. These metal pieces here were Corbels and some other metal details from a station kit that I never intended to build. And so I just rusted them up and made a pile. Just a pile of stones can be a pretty useful scenic device. These 2 photos, the one here on the left and in the center of the second row, are a slightly different technique. Most of the piles I've made have been individually placed and glued elements, but in this case, what I did was just drop a handful of scrap wood out of my scrap wood drawer onto a piece of wax paper or pallet paper, and then wetted it and dribbled dilute white glue over it, just like I would do in some other scenic situations. And it took a couple of applications of the glue, but turned out okay, except that the larger piece fell apart. So these 2 pieces, this one, excuse me, this one and this one were at one time intended to be a larger pile, and they broke apart, so I made two different seams out of them. This is a pile of the ballast that I use on my layout, and this is another lumber pile, but these pieces are glued together individually or placed individually and glued with glue. And these two piles are just unnamed building materials that I glued in place with dilute white glue. And finally, this scene is mostly just natural materials. There's some junk mixed in, but it's mostly natural materials that are piled or that collect in a pile in a wetland area of my layout. Another material that can, or other things that can be used interestingly in scenes are various building materials. A couple you might not think of are rolls of tar paper. These rolls are just construction paper cut into strips, rolled up, and then wrapped with a little piece of white tape and just some scribbling on a tape to make it look like there might be some labels printed or something. And the second case are some shingle bundles I made from leftover shingles I had from another project. I made this tiny little box as a jig to hold individual shingles as I glued them together, and then wrapped the bundles, the resulting bundles, with a narrow strip of construction paper. And these, to my eye, look adequately like the rolls of tar paper and shingle bundles that I see when I go to Home Depot. Another thing you can make, if you're so inclined, are pulleys. I acquired a couple of years ago one of these circle punches. I thought that I really needed to be able to make circles. It turns out I haven't used the punch a whole lot, and so I'm not necessarily advocating it. But if you are interested, one of the nice uses of these punches is to make pulleys from styrene sheet. So the way these punches work is you put the sheet of styrene or other relatively thin material clamped between an upper and lower metal steel bar with holes, precise holes drilled, and then you drive a peg through the corresponding die to make a circle. Here I'm set up to make a 3/16 inch circle, and the punch is now in the hole, so I just hit it with a hammer and punch out. The two outer discs in this case are styrene discs, 3/16 inch in diameter, which means 9 inches in 9 scale inches in O scale. And then the center disc that's glued on here was punched from an 1/8 inch piece of slightly thicker styrene. When I was gluing them together, I used a square corner to push the pieces into, so that in gluing the final side onto the original, things are pretty well centered and squared away. And the result looks like this in cross section, or here it's shown with a piece of thread thrown through it. This kind of gives an idea that although this is a 9 inch diameter pulley, it's still pretty small compared to the thread. Another thing I've been interested in is making cable reels. It seems like every place I've traveled, I see cable reels around in various warehouse lots and so forth. And I like to work with wood. So originally I hoped to make some cable reels with wood. Excuse me. I did discover that this circle punch is not ideal for working with wood. It tends to tear the edges a little bit. The wood compresses and then the edges tear a little bit. So instead, I just glued up a panel of 1x4 wood strips and taped a washer with double-sided tape. And then I cut around the washer and sanded, trimmed around the washer, added braces. And so I had an end for such a cable reel, and the center core of the cable reel is just a piece of dowel covered with 1x4 strip wood. And these are some of the cable reels I made using those methods. I actually had some cable from Cloverleaf. Is it Cloverleaf or Clover Hill models anyway? That I've always found too stiff to use for anything else, but I was able to wrap some of it around one of the larger reels and turned out okay. But actually, if you want to make cable reels, I think probably styrene is a better idea than wood. Here I've got, these are 3/4 inch discs that I made from the circle press, circle stamp, and they're 3/4 inches, 3/4 inch of my scale is 3 feet. So these are fairly large, but not huge cable reels. And these are all the pieces I'm going to use in putting them together. The scribed styrene sheet is a little bit thick. It's 40 thousandths, which is 2 inches. So instead of 1x4 material, this is in scale, it's 2x4 material. I don't think there are very many cable reels are made with 2x4s. However, the end result is more satisfying. One little thing that I just happened, I didn't plan it this way, but it turns out to be pretty useful. It's nice to get the first, when you're sheathing the interior, the central axis, it's nice if it's square and perpendicular to the ends of the axis. Well, it just turns out that ordinary clamp clothespin provides the answer, because when you clamp these a piece of styrene tube and a short piece of styrene strip together in this circular receptacle, they just sort of naturally square up. That may be a hint that's useful for other purposes too. I just discovered it recently, and so I don't know yet. This slide shows the application of the sheathing to the center core. I tend to make these longer and then trim as I go, just because cutting them to exact length makes it harder to position them when you're doing the assembly. And then I sand the ends a little bit to square them up. Glue the core to one of the sides just by eye, and then make up a square corner to glue the second side on. This is the result, and then I just sprayed it with a rattle can primer of a kind of a wood tone color, and dusted it with, well, first I washed it with alcohol stain and then dusted with pan pastels. And you can see here the edges look a little bit thick because of the thickness of the styrene, but they're not bad. I'm satisfied with that. If you're a real fanatic about that, you could scribe some thinner styrene to make your own. Anyway, I think if you want to make cable reels, styrene is probably a better approach than wood. I needed some big buckets for a ash pit on my layout. These are really big buckets. And I remembered when I was in high school being fascinated with a Paul Larson article about a coaling station on a branch line in Wisconsin. And I thought those buckets were just what I was looking for. Paul Larson, of course, used brass sheet and soldering techniques to make his buckets. That was before anybody was working much with styrene. But I adapted his ideas to styrene and wrapped thin styrene around a 1/2-inch dowel and then inserted a segment of the dowel itself for the bottom of the bucket. And then added styrene strips around the top and a wire handle, and then weathered it, heavily weathered it, in this case with chalks and local dark rust. This is a dark rust that I mentioned, I believe, in at least one and maybe both of my previous clinics. It's a color that's 1/3 roof brown and 2/3 rust in the old focal colors, and it's a really good rust color. I want to emphasize that this is a very large bucket. It's about 9 cubic feet compared to 2 cubic feet or less for a 5-gallon bucket. And it would weigh about 325 pounds loaded with ash if my finding on Google about the weight of ash is correct. I also tried making some large buckets using a different technique, a styrene tube. Instead of wrapping sheet styrene around a dowel, I just took a 7/16 inch styrene tube, thinned the end a little bit with a ream so that styrene tubing tends to be a little thick. So it needs to be thinned if you have an exposed edge. So I cut a segment of that, closed the bottom with a piece of styrene sheet, and added straps top to bottom. Then a brass wire handle, and again weathered it with, this time I just sprayed it with flat back and then dusted it with pan pastels. And this bucket's only about half the size of the large bucket I described earlier, because that was the size styrene tube that I had available. Here is the original bucket, and this is the one that I made with styrene tubing. You can see that there's a difference in size, but they're both large buckets. A bucket that you might find more useful is just a regular 5-gallon bucket, and that can be simulated pretty well in O scale with a 1/4-inch tube. A 5-gallon bucket is just about 12 inches in diameter. So I cut a segment of 1/4-inch styrene tube, thinned the edge, glued in a bottom, added a handle of very thin brass wire, 0.010 of an inch, and then weathered it and got a bucket like this, which is only about a little over 1/2 cubic foot. This critter I built a few years ago has several elements that were hand made. First was the fuel tank shown here, and in this slide shown before it was painted, just a styrene tube with styrene tubing on the top, some styrene strip for banding, angle styrene for legs, and so forth. The sand dome was actually a wood dowel that I clamped in my drill press, turned the end around, trimmed it with a file and sandpaper, then added a disc. I can't remember whether I used a metal washer or a styrene disc at the base, and a large nut bolt washer casting on the top. Gave me a sand dome. The exhaust pipe with muffler is just two pieces of styrene tubing with the outer piece drilled with small holes. The non-operative headlamp was made from several pieces of styrene tubing, styrene bracket, painted the inside of the thing with silver paint, and then added a plastic lens. The air tank is just a styrene tube with the end sealed by styrene, sanded up, and some straps of styrene strip. On the hood, the hinges are just half round styrene strip on other little bits of styrene, and the louvers are surprisingly just bits of styrene strip. They look pretty good, I think. Another thing you might have to build are some benches. I had a station I was modeling that had this very elaborate bench on the platform, and I thought I could do it with some brass bar that I had. I was going to solder up some leg and arm assemblies, but it turned out that soldering demands much exceeded my skill, and so I gave up on that, and instead I laid out this very simplified idea of the leg forms on styrene. I drilled out the waste material shown by the dotted circles, and then I carved a little bit the detail with X-Acto knife and smoothed with files and sanding sticks. And then I made the seats with styrene strips on styrene supports, and used fairly heavy material for these cross members under the styrene seats, so that I could first of all glue some brass arm supports between the slats with ACC, and then I drilled holes in the back of these styrene supports and put the verticals also from brass up the back. And then I added these arm rests bent from brass. I don't remember why this thing is primed in blue. It must just be that I had some blue that I wanted to use. I don't know. But anyway, that was what it came out. And the end result is crude, obviously, but I think very effective. From 2 or 3 feet away, it looks quite satisfactory. I'm very satisfied with it. Nevertheless, for other applications of similar type benches, I've simplified the bench itself and just made a squarish bench with styrene strip and this little jig that makes it easier to get nice square connections on the leg assemblies. You may or may not need some roof vents. I've needed several different roof vents on my projects. This one is a wood block in the center with angle styrene on the corners and a little piece of a styrene chip across the top. This one, I believe, is a wood block, but I can't remember, and my notes are not very clear on this. I believe it's a wood block with just a couple of pieces of brass wire and a piece of brass sheet bent over the top. This one was more complicated, and I'm sorry to report that I don't have notes. I've advocated keeping a diary and taking a lot of photos of your work in progress, but I failed myself in this constructing this vent. So I know it's mainly styrene, angles on the corners, and sheet or strip around the sides. But what I can't tell you is exactly how I assembled the ventilating slots. Now, I've got fascinated for a while with chimneys, and there are a lot of ways you can make chimneys, of course. The easiest is to wrap a wood block with brick paper. And these are two examples of that kind of chimney. In this case, again, the styrene tubes are a little bit thick, so you probably want to thin at least the top edge of this styrene tube with either a drill or a ring. But the most creative thing I did, I suppose, was a discovery that I could make a pretty good looking chimney with just stacking alternating chips of 2-inch scale thick material for the brick layers with 1/2-inch thick material for the mortar layers, and then scribing vertical lines for the bricks. So this shows a simple drawing to illustrate the point. It's a chimney that's just 2 bricks square. And so one course looks like this, a 2-inch brick layer scribed twice, and then a 1/2-inch mortar layer. And the next chip layer looks like this, with a 2-inch brick layer scribed once and a 1/2-inch mortar layer. Pile them up until you get the chimney of the size you think you need. So inscribing so I made up a bunch of these chips like this on this slide, and then to make the horizontal brick scribes, you need to grip this chip very carefully and solidly because it can be kind of dangerous. And then make the scribes with whatever works for you. A file might work. I used a number 11 blade pressed quite firmly. And I've also even used a little, just take a nip out of that with a small side cutter, miniature side cutter. So then you need to then have a kind of a jig so you can stack these chip pieces together and weld them together with liquid adhesive, and be certain that the chips with one side with one scribe line and the chips with 2 scribe lines alternate, so that the final stack of bricks will look right. So then you complete the brick layers. In this case, my chimney had a tapered top, and so the layers, upper layers got narrower and narrower. The final layer was just strip styrene, no chip involved. Then paint it with some red brick color. Boxcar red's not a bad brick color. I've recently been using this Rust-Oleum claret wine color for painting the bricks. And then I use Durham's water putty for mortar. The way that water putty works, you just mix it up pretty thin, brush it on, leave it for only a couple minutes, and then wipe it off with a damp cloth. And you get a pretty nice effect. This was the prototype chimney I was modeling, and this is my model. I've also used the same technique on these very large chimneys from the drying kiln on my shingle mill on my layout. These didn't turn out as well. They probably are expensive waste of a lot of styrene to make chimneys this large. These chimneys are probably 3/4 of an inch by 2.5 or 3 inches. And by 3 inches high. They're pretty big chimneys. Another technique I've played with a little bit is to use the same kind of chips, but install individual bricks of styrene around the edges. So I use this jig to make it easy to get the corners spaced right, and then filled in between the corners with bricks spacing by eye. And then, so this represents a whole chip now with a mortar patch to separate it from the next chip, and then these are stacked. You got to remember here to flip every other brick layer 180 degrees so that the overlaps of the bricks work out correctly. And then this technique with individual bricks can give you a little more rundown appearance. Like this chimney looks very realistic on a rundown building. And then I've also done some individual bricks of wood. Here I make a wood core. It's attached to some kind of a scrap sheet so that I can work it in an upright position. The bricks are alternated with strips of styrene around the edges for the mortar lines. And then when painted, the result is like this. Another one, this is a little smaller chimney. And this one, incidentally, the brick chases tended to started to get out of alignment, so that there was kind of a cant off to one side of the chimney, and so I cut it off pretty short and just put a cement top with a tube on it. And these are two of the results from individual wood bricks. I saw a very useful hint on a convention clinic from last year's NMRA virtual convention. If you ever want to do anything with individual bricks or other individual pieces that are small like bricks, chopping them is not the way to go, because not only is it very tedious, but they don't come out exactly the same size. Instead, what you should do is glue strips of the material you're cutting onto some kind of a backing with double stick tape, and then either run them through a saw or cut them with repeated draws of an X-Acto blade. And then you can produce a lot of uniform size bricks or other such materials in short order. Another project I think you might find useful are barrel racks. Here, I'm just using this assembly tray to create a cross-legged end of the barrel rack and adding a brace. And then I use this little piece of scrap balsa wood with 2 slots cut in it to help assemble 2 of these leg systems, and ended up with this kind of barrel rack. Or the second barrel rack I was to show you here is kind of like a workbench with glued up sides or tops and bottoms fastened together like with workbench legs, and 2 logs or 2 barrels installed. One of the kits I built some time ago had some sawhorses in it, and I thought that was a pretty neat idea. And so I made these 2 jigs from thin plywood, double layer of thin plywood that this shows the front and this the back. And I had intended that I would clamp those 2 ends together around a core, as shown in this thing, and then build a sawhorse, and then get it out of the jig by unclamping it and just releasing the middle. But that didn't work very well because this critical joint here, where the cross piece goes, just wasn't strong enough to hold it all together. So I settled on a different procedure. I can use the same jigs for the 2 sides. I assemble them with oversized braces, and then I sand the tops of the legs with a sanding stick. So the joint I'm trying to make requires that the tops of the legs be squared off like this. So I take these 2 leg assemblies, sand them a bit to get this configuration, remove them from a jig and trim the braces, and then just glue in the 2x6 cross member. Another thing that you might find useful are pallets. This also idea came from a kit I had built a few years ago. I did make the jigs myself. The styrene jigs are made by just gluing together various widths of styrene so that we can add first the runners and then the slats for a pallet. This shows the back sides of those 2 jigs. The first step is to insert 2x4 runners in the bottom jig, and then clip on the top jig, which accommodates the 1x5 slats. Then you glue in all the slats, remove the cover, and then very gently remove the assembly from the jig, which means pushing it out from the back rather than prying it out from the front. Add slats to the back, and then you have the finished product. And you can make this from the same jig. You can make various sizes depending on how long you make the runners and how many slats you add. Now I'd like to introduce you to making your own windows. These are double hung windows. Double hung means that the lower sash slides up behind the upper sash. It's kind of a classic kind of window. These are the main parts. The frame is perpendicular to the front of the photo, and then the trim are flat or horizontal to the front of the photo. And then there's the upper sash, the lower sash, the bottom is a sill. The windows I needed didn't have any apron, but you could add an apron at the bottom. And then if there are any cross members in the windows themselves, or in the sashes themselves, those are called muntins. The dimensions I used for my windows were a little bit large, a little bit bigger than scale, but they were the same size as some Grant Line stock that I had in my drawer. In particular, the frame and the trim are 1.5 by 5 instead of maybe 1 by 4, something like that. And the sill is 1.5 by 8, and the sashes and muntins are 1.5 by 1.5, all on styrene. These are scale dimensions. So the steps are fairly straightforward. Frankly, I spent quite a bit of time figuring out how to do this, but it's really, really simple. There's just not much to it. You make a drawing, put a jig around the drawing, then assemble a frame, add the trim around the edges. Then the only complicated part, I guess, and what I spent so much time figuring out was how to do the sashes. I made the sashes in 3 layers. Layer 1 looks like this, and it shows as the bottom layer in this side view. Layer 2 is just the upper portion, and it shows like this. Then layer 3 is an extra upper portion and an extra lower portion. And between layer 2 and layer 3, you add the glazing, which is the dark pine. So the way that works is after you got the thing assembled, you install the sash layers 1 and 2. Then you paint and install the glazing. Paint before you install the glazing, so you don't get paint on the glazing. Then add the final sash layer and muntins, which have been pre-painted. So remember, you're going to do layer 1 and layer 2, then paint. Then you add the glazing, and finally layer 3 and muntins if the windows have any muntins. I mean, once you've done it, it's really pretty straightforward. And doors can be done the same, sort of the same way. Materials were of the dimensions I'll show over here, and the transom is optional. If you don't want the transom, you just build up to the top of the door. Again, I used 1.5 by 5 inch trim and frame. The door panel itself, I used 0.040 styrene because that's what I had in hand. The stiles and upper rails are 1.5 by 4. Then these raised panels just happened that they turned out to be a pretty, in my scale anyway, turned out to be a pretty good standard size, 1.5 by 9. Again, you make a jig, assemble a frame, add the door panel, then add the rail stiles and the raised panels in the door, paint it, glaze it, and add a knob. And one other hint here is that the knobs I use are called bridal lace pins. I got them at Joann's, and they're exactly the right diameter for a doorknob. And again, you can do a freight door with a very similar technique. Make a little jig to work in, add frame and trim, then add the door. I used scribed styrene for the door in this case. And the trim. Some other architectural details include these finials. The station I built a while back had these finials, and while I had detailed plans for the lower finials on the ends and for the upper finial in the center, I really just wanted to get kind of the impression of those things. And so I carved the lower ones out of blocks of basswood, and the upper one I turned out of a piece of dowel rod by sticking it in an electric drill and hacking at it with a file and sandpaper. That same station project involved a lot of corbels, and they were very fancy corbels. This was a prototype drawing, and I knew I couldn't duplicate it, but I did want to capture of course, the angle, but also some of the curvature. So I settled on this kind of drawing with the dimensions exact scale, and the two radiuses here, and then the smaller radius here and here. And I fabricated them then using strip styrene and a 3-point jig, and these drill bits in my drill press that are called Forstner bits. Forstner bits allow you to drill not only large holes, but you can drill in the sides of things. You don't have to take out a whole hole. Whoops. So these are the jigs I used for that project. This was used to assemble them, and the legs here are oversized. But so I made the basic assembly. Then in step 2, I took out one of the small curves with a Forstner drill and one of the larger curves. And then I went to stage 3 and took out the opposite, the other larger curve and smaller curve. And I trimmed all them to exact dimensions. And this was a herd of them ready for paint. This is what they looked like in the final project, and I was pretty satisfied. And I have subsequently used the same jig to make these very plain supports for another awning. Another kind of architectural detail that I found useful involved paper siding, clapboard bevel siding. I took some self-adhesive paper, printed appropriately spaced lines on it in just regular inkjet printer, stained it up with neutral grays and then red iron pan pastels. I wasn't looking for a uniform color. I wanted variation because I wanted it to look worn. So then I ended up with a sheet like this and cut out the strips along the lines, and then applied those strips to a previously scribed siding, styrene siding. And I was very happy with the appearance, with the result. The weathered appearance was easily achieved with the pan pastels, and overlapping the paper strips gave me a good sense of depth. And I think that's a technique that's worth further experiment. Another kind of thing you might find useful is a pipe rack. Here I drew up some plans, and then I cut all the parts and applied aging and weathering to the wood pieces, and installed nut bolt washer castings. Then I made this little jig to assemble the leg sections. It allowed me to notice that the legs have these cross pieces on both sides, and so I used deep enough jig so that I could put in the pieces for one side, then turn it over and put in the pieces for the other side. And then here I'm using an ad hoc collection of methods to keep things kind of square while I'm connecting the leg sections. And when finished, I added some weathered tubes, rods, and other shapes. I actually made two of these pipe racks on my layout. This one doesn't have the nut bolt washer castings, and it's a little further from the front edge of the layout, so it doesn't show as much. And this one is right on the edge of the layout, and so it's fairly prominent. I did put in the nut bolt washer castings. Then this is almost like a structure, I guess, rather than a detail, but every layout probably needs a loading dock. And in my case, I had a package of scrap or surplus lumber that I had picked up years ago, and it had a lot of pieces in it that were almost the same thickness, but not the same thickness. And so I took advantage of that and created a pretty rough looking deck for this loading dock. The cleats on the ramp are because I anticipated the dock might be used occasionally for livestock, loading livestock. And I used a jig like this just to keep all these little legs perpendicular while I was adding the braces. I have found that any kind of project involving a lot of short little legs is hard to keep things in order. And so I found jig very useful. This is just shows the final setting for the loading dock. I'm getting near the end and want to mention a couple of useful commercial products that I think you should be aware of if you're not. First are the decal rivets that I think there are several companies that market them. I got mine from Micromark, but they're generally very useful. And then a few years ago at the NMRA convention in Portland, I picked up an HO kit for refinery piping. And it just turned out that the piping and the various valves and connectors are extremely useful to me in O scale, but I think they're oversized for most applications in HO scale. These are some things I've done with the decals on this critter project. I actually took strips of styrene and decaled those strips and applied them to the cab of the critter. For the water tower, instead, I applied the decal strips directly to overlapping sheets of styrene sheathing and roofing. And this is the result of the water tower project. And more recently, I had a few parts that I thought I could use on a fuel tank. And so I took a piece of closet rod, fairly large diameter dowel, and I applied rivet strips that were made by using just guiding lines on a self-adhesive paper, but I was worried that the rivets wouldn't stick to the raw paper, so I first sprayed it with some leftover appliance epoxy that I had. Probably other kinds of paint would have worked okay, but anyway, I used this epoxy paint. And so I applied these paper thin rivet strips to each end of this rounded over dowel rod, then added a commercial ladder and a dome. And the valve was actually a part of the refinery piping kit that I mentioned earlier. And this, oh, and then the base is just a couple of pieces of strip wood shaped and made to look like concrete. These are examples of the use of the piping. Here, all the piping and the valve are from the refinery kit. Similarly, here at this oil or this fuel distributor's place, this is some piping around the intake for the distributor, and these are places where an oil truck would come in and load up. I didn't have much to go on here. I was just faking this, but I kind of remembered something that looked sort of like this from things I saw when I was a kid. I want to say just a few words about interior details. I think it's kind of like scratch building, even when you use commercial items, because you're combining elements to create an effect. And I do in detail many of my structure interiors, but the payoff is really small. You know, unless you're a fanatic, I don't know if I could recommend it, but here are some ideas. This is a hotel office or waiting room, and the only commercial item in this scene is the clock face. My wife painted the paintings, and the other items are all just made from scrap wood. Of course, the photo is very low quality, but that's sort of the character of interior detail. It's hard to see. This bakery interior has a few commercial elements, but lots of scratch details. The divider, this wall here is cardstock with a wood shelf. The menu was small font computer print. This counter was just made from scrap wood. Cash register is a block of wood carved and covered with gold foil. Not real gold, gold foil. The stools are just slices of dowel on wire. And this table is scrap wood. There's a bench behind this table that's not particularly visible, but it's scrap wood. These dirty plates were punched out, not with my new circle punch, but with just a paper punch, punched out of styrene and smeared with paint. And the silverware is bits of solder with pinched ends. The cups are bits of dowel. And the window cake was, I think, stacked bits of dowel. The only commercial items were the wall clock and the poster came from scrap box. The lamp is from Western scale models, and these benches were out of a Bachmann coach. The general store, on the other hand, has a lot of commercial cabinetry, mostly from Banta Model Works. But of course, the cabinets had to be filled with stuff, and that requires more imagination. The station interior also has many commercial elements, mostly from Western scale models. But the impact is often small, even when lighted. Mostly, my layout is a fairly narrow shelf layout, so even up close, however, it's hard to see a lot of the interior detail, and unless it's lighted and the room is darkened, it's mostly unnoticed. I think it's like, I guess it's like the underbody detail on your freight cars. the benefit is in knowing that it's there. Of course, there are exceptions. I have some buildings with big doors or open walls. This is from a gas station, little gas station interior, and this is an engine house, and those details are a lot more visible. This engine shelter and the big door on this blacksmith shop allow pretty ready visibility. Incidentally, this little grinder was one of the most difficult models I've ever built. It was part of a kit, but very tricky. Some things you can do for interiors, of course, that are easy to do are workbenches. Several examples here. And they can even be outdoor workbenches. Cabinets, these are really just blocks of wood with strip wood applied. Or counters. This is a station interior counter. I showed you earlier the counter from a hotel and bakery. And then these are some interior benches, these waiting room benches. I kind of jimmied up or jerried up this profile for the bench ends, made it full size and glued it onto styrene sheet and then shaped around it to make the ends of these two benches and join them with styrene strips and then stain them with local stain. And that's probably everything I know. Any questions or comments?
Yeah, this is following Ron's technique, gluing board by board. It's just a tube from a roll of tape. You use a square to scribe some lines and just glued board by board. It's pretty easy. One comment about your cable reels, Ron. You need an axle hole in the ends.
Well, is that true? I didn't remember seeing cable reels, axle holes in the cable reels. But yeah, some of them would surely have. Axles. Yeah.
The ones that we worked with, like when I was talking earlier about working heavy construction as an electrician's helper, they had these racks, and they'd use, I don't know, it was like 2 or 2.5 inch pipe that would go through the hole in the big reels, and then they could unreel it, pull it off.
That makes a lot of sense. I mostly observed real life cable reels from quite a distance, and there were probably axle holes that I didn't see.
The axle holes are covered when they're shipping it.
That could be.
I'm just kidding.
Oh, well,
yeah, that's a good point, Phil.
Yeah, but that's something that a whole lot of people would never notice.
Right.
Yeah, thank you very much, Ron. This is excellent. Lots of interesting detail ideas. One thing I noticed that I liked was that one pile of sand or gravel, and you had the wheelbarrow by it with the notch out of the pile.
Yeah.
I thought, even without a figure there, that adds some life to the scene.
Yeah.
Something has been going on because they've been digging in that pile. So
yeah, I remember making that pile. I used a vertical piece of dowel held in place with a third hand while I was gluing that pile down, and that's how I got that shape. I've spent a lot of time during the pandemic working on these clinics, and I'm very pleased to have the opportunity to present some of this stuff, because otherwise I was just kind of entertaining myself,
Oh, it was good.